Okay, we're in exercise 68, a set of problems. We're in the exercises. And I'm looking at problem number 2. And again, I can't say this enough times to you, a piece of paper, a pencil, try to solve it. And someone says, well, I'm going to guess at this one. We're not saying not to guess at it. What we're saying is we're trying to learn some skills of algebra. And that's what I'm going to do. I'm going to attack this problem using algebra. All right, so I'm going to go to the whiteboard. I'm done with this. I'm going to go to the whiteboard. And this is my whiteboard. I'll blow it up. I'll get my pen out. And make sure I got a pen here. Yeah, I got a pen. And we're doing problem number 2. And again, we're in exercise 68. So what I want to do is, I want to write the system down, and the system is this: x squared yz equals 12. And the second equation is x y squared z equals 6. The third equation is x y z squared is equal to 18. Again, I want to discourage you from just copying. Reason being, you might copy wrong and waste a lot of time solving something you can't solve. All right, so, I'm going to say, kind of looking at it, and I got to be careful here. So what I'm going to do is looking at, you could do divisions. We just did that in the prior problem. I'm seeing something here, though, and I'll tell you what I'm seeing. If I multiply these things out, all three equations, I'll write that down for you. If I took x squared yz, and I multiply it by the second, which is x y squared z, and multiply by the third, x y z squared, and that would be 12 times 6 times 18. It looks nightmare. If it is, I can always erase it, by the way. But I do notice something. I notice I get x, y, z to the 4th power. And that would equal, I don't know if I want to multiply that out. And I'll tell you the reason why. I'm just gonna write down some factors here. And I'm gonna write down 3 times 4, and 3 times 2, and 2 times 9. And I'm starting to realize, just counting it up, there's 1, 2, 4 factors of 3. And how many factors of 2 are there? 1, 2, and there's 2 there, and there's 4 factors of 2. So x, y, z to the 4th power. All right? So then the big question is, what would you get for x, y, z? Well, x, y, z could be plus or minus 3 times 2, which is 6. All right? That does present a problem for me because there's 2 possibilities for that. So what I want to do is go back to the original system and kind of look around, see what I can get. Like in the first equation, what do I got? I got x times x, y, z equals 12. What I get in the second equation, I get y times x, y, z equals 6. What I get in the third equation, I get z times x, y, z equals 18. That's convenient, all right? So what I want to do is I want to say x, y, z. I'll take 2 cases. If x, y, z is equal to 6, and the other case is when x, y, z equals minus 6. And let's write these down. So what would x be? Well, I'm kind of looking at it, and it's going to be, well, you would get 6x is 12, so it x would have to be 2. What would y be equal to? Well, again, x, y, z is 6, so, that would mean y is 1. I'm just looking at these equations over here, by the way. What would z equal? This is getting pretty easy, isn't it? 3. Let's put this one over here. X, y, and z. What do you get there? Minus 2, minus 1, and minus 3. We'll look at the answer key later, but I do want to write the triple down. What's it going to be? 2, 1, 3. That's one answer. The other answer is going to be minus 2, minus 1, minus 3. Again, we provide answer keys, and the reason being is we want you to look at the answer keys. So let's take a look, and I'll see what I got over here. Oh, you know what? I didn't consider the complex ones. I'll go over that in a minute. But I looked at my key, and I started to realize, you know what? I didn't look for other solutions that might be complex. And the reason for that, I'm not expecting to write them down. And I want to tell you, in Wells' book, they also didn't write the complex solutions down. But I want to go through that with you. All right? Now, someone says, do you need to go there? No, because I think, for the most part, if you look at Wells' answer key, And I don't know if he had an answer to this one or not, but he would have just written those two answers down. He wouldn't have gone elsewhere with that. What I want to do is I want to talk about, why they're talking about complex solutions to the problem. And so I'm going to put this over here. So x, y, z to the fourth power is equal to, as I said, it's really not a bad number. It's going to be 6 to the fourth power. Well, certainly, obvious answer to this one, we wrote those down, x, y, z could be plus or minus 6. That's the obvious one. Let me just talk about the complex ones briefly. So x, y, z, and again, I'm just writing down the fourth power, is going to be 6 to the fourth power, right? And the other answers that work, I'll write these down for you. X, Y, Z could be 6i, or X, Y, Z could be minus 6i. Let me just go through that with you. So if you took 6i and put it to the fourth power, you certainly get 6 to the fourth power, but you also get I to the fourth power. And let me just review that with you. 6 to the fourth, I'm kind of expecting it, I squared. What's I squared? It's minus 1. And what's minus 1 squared? It's 1. So you still get 6 to the fourth. Now, if I did the other one, minus 6i to the fourth power, well, if I did that, that's minus 6 to the fourth, I to the fourth. This is going to be 6 to the fourth. And we just did I to the fourth at just 1. It's still going to be the same answer. So maybe I should write those down too. So let's say x, y, z is 6i. And let's say x, y, z is minus 6i. And again, we're going back over here to this over here, and fairly simple to do, all right? So what are you going to get? Let's write this down. We're going to write down x, y, and z here. And we're going to down x, y, and z here. Well, if x is 6i, oh boy, that's going to be a tough one, isn't it? So if x is 6i, I'm sorry, x, y, z is 6i, what would you get? That would be minus 2i. And this would be minus I. Not so bad, I guess. Minus 3i. Right? If you want to verify that, I want to put on, x times x, y, z has to be 12. And what's x? I said it's minus 2i. What did I say? The x, y, z is 6i. And I want to verify that this is 12. What are you going to get up there? Minus 12i squared. And what's I squared? It's minus 1, so this works out. And you may want to check those out. What's this guy over here going to be? 2i, I, and 3i. So we got our triples. Let's put them down for you. Whoops. Our triples are going to be minus 2i, minus I, minus 3i. And again, as if you were doing complex numbers, 2i, I, and 3i. And certainly, if you want, you can check those guys. I realize it might be confusing. And, to be honest with you, Wells didn't go there. But I did list all 4 answers down for you. I listed down the 2, 1, 3, minus 2, minus 1, minus 3. I listed 2i, I, and 3i. And I listed minus 2i, minus I, and minus 3i. So everything's been listed. So we're done. Good deal. We're going to need to move on. Thank you so much for paying attention.